Hello, this is Biostatistics NW395N, and this lecture will be on comparing group means, and this is your instructor, Dr. Marge Benham-Hutchins. This presentation will cover tests for comparing group means. The t-tests, various types of ANOVAs, ANCOVA, MANOVA, ANCOVA, and then some resources to help you with more details on some of these more complex tests. The content for this lecture is coming from the chapter readings, Kim and Mallory, 11 and 12, and Cronk, chapter 7. The learning objectives for this presentation include understanding the approaches to the different testing and which testing would be used to answer different types of research questions, to evaluate the assumptions of the different tests, distinguish how the number of groups would influence your choice of a statistical test for difference, and to distinguish between t-tests and one-way analysis of variance, ANOVAs, from some of the more advanced ANOVA designs, which are factorial ANOVA, repeated measure ANOVA, ANCOVA, multivariate analysis of variance, MANOVA, and multivariate analysis of covariance. So choosing the right statistical test when you want to compare means depends upon the proposed research questions and consideration of different factors, such as the number of groups, whether the groups are independent or dependent, are they univariate versus multivariate, do you have one variable or multiple variables, the number of independent variables, and the possible existence of covariates. The Cronk book on page 150, Appendix F, is selecting the appropriate inferential test. This is the written narrative that goes with the chart that's on the inside the front cover of the Cronk book. And it starts out by asking what your main question and then goes through a flowchart to help you select tests. This is not just for tests that have to do with mean, but it's something that I think you should review and be familiar with. So we'll start by talking about t-tests. You should be familiar with these because during Unit 2, one of your homework assignments was working on t-tests and learning how to do them in SPSS. I did this and so that you would become familiar with this type of test that compares means before we went on to the more complex ANOVA tests. So this is the simplest t-test where it compares the mean scores of a sample on a continuous dependent variable to a known variable. This could be comparing the mean IQ of a sample of students from the university to a known average IQ for the university, similar to one of the homework test questions. The t-tests can be one-tailed or two-tailed. And remember, you can identify which one-tailed or two-tailed, by reviewing the hypothesis. If it is directional, mention something is greater than or less than, then it is one-tailed. Remember to divide the two-tailed significance by 2 for the one-tailed significance when you are evaluating your test results, and report it correctly when you are phrasing results for publication or reporting in a paper. So you may recall from last week's homework that the assumptions of one sample t-test is that the population mean should be known, the sample should be randomly taken from the population, and the subjects within the sample should be independent of each other, and the dependent variable should be continuous and normally distributed. The hypotheses for a one sample t-test are: the null hypothesis is that there is no significant difference between the sample mean and a known population mean. And the alternative hypothesis is that there is a significant difference between the sample mean and a known population mean. The example in the little box there is just assigning the number 120 as the known value. So you may recall from your homework last week that the t-tests for independent groups. Here the assumptions are that the sampling distribution is normal, the data is measured at an interval level, The variances in each group should be about the same, and measurements should be independent. Your null hypothesis is that there is no significant difference between the group 1 mean and the group 2 mean. And your alternative hypothesis is that there is a significant difference between the group 1 mean and the group 2 mean. Once again, remember that if this is a one-tailed test, there would be a directional hypothesis. So now we'll talk briefly about the t-test for dependent groups. Again, the assumptions are that the sampling distribution should be normal and the data should be measured at the interval level. These groups are dependent on one another, so there's some sort of a relationship there. Your null hypothesis is that there is no significant difference between before and after measurements. And the alternative hypothesis is that there is a significant difference between before measurements and after measurements. So this may be similar to the question on the homework that asked about midterm grades and final grades. That one was looking for a difference between measurements, but it also was directional because it was asking whether they were higher for the final, if there was an improvement between the midterm and the final grades. So now we'll move on to discussing analysis of variance, which is called ANOVA. This is a group comparison test for more than 2 independent groups. You could potentially run multiple t-tests instead of an ANOVA, but that would lead to the inflation of type 1 error, which means that it would increase the likelihood that you will draw an inappropriate conclusion. The ANOVA compensates for this for these multiple comparisons and gives you a single answer that tells you if any of the group is different from if any group is different from any other group. The assumptions here is that the sampling distribution should be normal. The data should be measured at least at interval level. Variances in each group should be about the same, and measurements should be independent. So the ANOVA, the analysis of variance, the hypotheses would be, your null hypothesis is that there is no significant difference between group means, and your alternative is that at least 2 group means will differ. When you're making your decision about your results, you would look at your p-value, and if it is less than your chosen alpha, your significance level, the group means are said to be different. But this only indicates that there are at least 2 groups that are means that differ, not which group differs from which group. So you have to run post hoc tests that tell you which are different. So when you're reporting the results, it's important to include the post hoc analysis. When you work on Cronk Chapter 7, he will walk you through how to do a post hoc analysis using Tukey's HSD post hoc test. There are others. And if the p-value is greater than the chosen alpha, the group means are said to be the same, and you do not need to continue on and do a post hoc test. So we're going to quickly revisit choosing the right statistical test before we move on to the other types of ANOVA models. If you recall, the factors to consider are the number of dependent variables, the number of independent variables, and the possible existence of covariance. So just as a quick review, the dependent variable is the outcome variable that is affected or influenced by the independent variable, and the independent variable influences the dependent variable and may be controlled or manipulated by the investigator to affect the dependent variable. So covariance exists when 2 variables are related to each other and may influence the dependent variable, but they are not an independent variable. So a little bit more on choosing the right statistical test. There could be some situations where more than one independent or dependent variables are to be examined. For example, it's likely that starting smoking is associated with several factors. It could be exposure to smoking in the family environment, peer pressure, access to tobacco products, cognitive capacity. There are a variety of things that may influence smoking. So if you're running three separate ANOVAs, just like earlier when we talked about running three separate t-tests instead of an ANOVA, will result in a type 1 error where you're likely to draw the wrong conclusion. A better design is a multivariate design where all three dependent variables are simultaneously examined. This allows us to examine the relationship between the dependent variables at the same time. So let's now talk about factorial ANOVA. This ANOVA design is with more than one independent variable. This can be a powerful test because you can assess the effects of each independent variable plus the effects of the interaction between the variables. These interactions occur and cause an effect from one variable when one variable impacts the effect of another variable on the dependent variable. So this requires all the assumptions of a one-way ANOVA. Dependent variable can be interval or ratio and normally distributed. Independent variables are independent of one another. So now let's talk about repeated measures ANOVA. This is a common test that is used in nursing research, and it's a simple extension of the dependent samples t-test, but there are more than two repeated measurements. These multiple measurements of the dependent variable should be from the same or related participants. The assumptions are that all these are the same as the assumptions for the dependent samples t-test and the assumption of sphericity. And this is the assumption that the different scores of paired levels of the repeated measures factor have equal variance. In Croc section 7.4, you'll have the opportunity to run, interpret, and phrase the results of a repeated measures ANOVA. I encourage you, if you plan to use this test in your own research, that you expand upon what is covered here in this class and talk to a statistician or get an advanced textbook to learn more about how to investigate if the assumption of sphericity is violated, and if it is, how to run the additional tests, such as Mauchly's, Greenhouse Geisler's, and I think it's Winfield tests. And this is really important and a bit beyond the scope of this class. But if you do run this, and it is a common test that people will use for nursing research, be sure to include that and to not forget about these particular tests. I want to talk briefly about the advantages and disadvantages of the repeated measures ANOVA. One of the advantages is that it's suitable when some variables are to be measured repeatedly over time, such as a longitudinal design. It's economical design compared to some of the independent sample group comparisons, since the sample size is smaller than when you have more than one group. And since it analyzes only one group, the variability is lower than multi-group design, and therefore the validity of the results may be higher. The disadvantages include that repeated measurements may not be possible due to dropout. That is, that your participants don't continue to participate through the whole longitudinal time period. This may be to death, or you just lose them, or they decide to drop out of the study. There may be a maturation effect where the subjects may change over the course of the study. So in other words, if you're doing something longitudinal and it is with children and they age, there may be some factors included in their aging that are influencing your results. And so you have to really take that into consideration. It also could be with illness. It could be a quality of life study, for instance, that you're looking at and the patients have some serious chronic disease that then gets worse, and so your responses may change because the patient themselves is changing. And then there also could be other effects that hurt the validity of results, such as subject scores shifting toward the average with multiple measurements. So now let's talk about ANCOVA, analysis of covariance. This is an ANOVA when you control for the effect of a covariate or covariance. It has the same assumptions as an ANOVA, but you also have to be sure that there's independence between the covariate and the independent variable. and the regression slope is homogeneous, which means the lines expressing these linear relationships are all parallel. Your hypotheses are, your null hypothesis is that there is no significant difference among group means after the means are adjusted for the covariate, and your alternative hypothesis is that at least two group means differ after the means are adjusted for the covariate. So now let's take a look at the MANOVA, multivariate analysis of variance. Like with the ANOVA, running multiple univariate tests, one for each dependent variable, risks type 1 error. Multivariate tests look at all the dependent variables at once, much like the ANOVA looks at all levels of the independent variable at once. So in other words, the MANOVA is an extension of the ANOVA, where more than one dependent variables are simultaneously examined for group differences. This is a more complex design. It requires a larger sample size. It has all the assumptions of the ANOVA, multivariate normality, independence, and that the covariances are homogeneous. The null hypothesis is that there is no significant difference between group means on any of the dependent variables, and the alternative hypothesis is that there is a significant difference between group means on some of the dependent variables. In Cronk section 7.7, he provides the opportunity for you to run, interpret, and phrase a MANOVA test. This is another test that will require information beyond this course if you're going to use it in your research. A statistician or an advanced stats book can help you design the test correctly and plan for any follow-up tests of significant MANOVA results, such as running one-way ANOVAs, discriminant analysis, or Roy-Bargmann step-down analysis. So I will just touch on MANCOVA, multivariate analysis of covariance, mostly to help you understand that this is a different test than the MANOVA. This is a multivariate analysis of covariance, so it's a MANCOVA, and it is used to control for the effect of covariates on the combination of independent variables. This is a rather complex test, and it's not covered in the Cronk book, and I think it's just touched upon in our other textbook. But this might be something that you will be faced with wanting to use in the future, and I recommend that you look for additional resources on this. And one of the books that I have found very useful if you're using SPSS is Andy Field's Discovering Statistics Using SPSS. I listed the second edition here, but there are more editions since then, and the older editions are also excellent, but you just have to realize that they may be talking about a little bit different version of SPSS than what you would be using, but a lot of times the changes are not that significant that it doesn't work, and you probably could get a good deal on a used copy. And he walks people through it. He has a good sense of humor, and it's a book that I relied on tremendously during my doctoral studies. Another book that I like is The Analysis of Covariances and Alternatives, and this book is one that really does focus a lot more on these particular types of tests, but also will give you a lot more detail if you are planning to use them. And as I mentioned before, ask a statistician. We here at the School of Nursing have a statistician, and UT also has a statistical department where you can make appointments and talk to them about what tests you're talking about doing. They can also help you in things like writing up the results, publishing, and that type of thing. Ask them for book recommendations. Quite often they have a favorite, or one that they know will help you understand and run a specific test, or in some cases they may even have handouts that will help you. Thank you for your attention, And I would like to ask you, if you have any questions, to please post them in the frequently asked question area in Canvas so I can answer for the class. Please don't hesitate to ask a question in that area. If you're really reluctant, you can email the question to me, and then I could either post it anonymously, or I might ask you to just post the answer to the question for the class's benefit also. My experience has been that if one student has a question, there are others thinking the same thing. I know this is a very complex lecture and is a bit of an alphabet soup, but the important thing is to realize that you have resources available to help you as you're moving forward, and to be familiar enough with the tests that you can look it up. You'll have access to your Cronk book and the other book and many other resources as you move forward, so that you could either refresh your memory or assure yourself that you're running a test correctly. And once again, thank you for your attention.